Cool. So, so this is uh, actually, before I get into this, let me very quickly get this idea across of fundamentally what are we doing in the core stack? Yeah, or what we call the core stack data structure. So some of these links are useful, especially for folks who are just getting familiar with the core stack. Yeah. Um, so this is basically how it works. Yeah. That we have a bunch of um pipelines. Yeah. At the back end, what happens is, right? So this is the core stack GitHub page for the core stack backend repo. Um, that for any area, we are collecting or building a lot of different data sets, right? About precipitation, evapotranspiration, all sorts of things, cropping, terrain, yeah, changes in tree cover, changes in land use, and so on. Yeah. So all of these are different pipelines that run. And what they do is they generate, so these are what are called stack specs. This is a metadata describing the core stack data structure. So what they do is they generate these pipelines are run for a state, district, and tehsil. And for this tehsil, all of these different layers are what are generated. So how is land use changing over time? Or in this micro watershed, yeah, it tells you the metadata that how much area, what is the area of the micro watershed? How much area has changed from double cropping to single cropping? So it has reduced, right? Or double cropping to triple cropping. So the cropping intensity has increased. Yeah. Single to double, single to triple, and so on, right? So that whole uh, matrix of changes from one class to another class, right? So this is just one of the examples. But in this way, right, there's administrative boundaries where the entities are villages, and it talks about what is the development index of the village across different years, what kind of right, what's the percentage of households with different levels of bathroom access to bathroom facility, yeah, and so on, yeah. So this data, for example, was brought in from the census, and the cropping intensity data was brought in from land use land cover layers, yeah. So what right, so this is the Earth Engine asset where we have generated land use land cover for different years, right? That for each pixel, we've run machine learning classifiers that have said, right, which of these pixels is a built up area, right? So this is Delhi and so on. Which of these are water bodies? So this is probably some part of some river or some stuff which is happening, right? And then whether there is some cropping and different things happening in these areas, right? So, so those base, what the pipelines did is that they use these kind of base rasters and they intersected them with micro watershed boundaries. Yeah. So they intersected that in this micro watershed, how much area is under single cropping, double cropping, triple cropping, and so on. Yeah. And then what they did is that the stack specs, for example, that I was showing, um, those stack specs were then generated that it picked up the cropping intensity layers, which are showing that across different years, what kind of pixel level changes have happened from single to double and so on. Yeah. And then it picked up the cropping intensity. It built this computed layer, oops, of cropping intensity, um, which then calculates that in this particular micro watershed, yeah, in this micro watershed, what is the area of this micro watershed, and of that, how much of that area has changed from double to single, double to triple, and so on. Yeah. So, yeah, so these are stack specs which are describing all the different data sets that are there in the core stack so far, right? So there's cropping intensity, water balance, tree cover changes, and so on, right? So all of these are for any tehsil, various pipelines run. The pipelines that I showed over here, right? So all of these pipelines run for any tehsil and they produce all these different maps. Yeah. And these maps and the statistics are what right are described in these metadata standards. Yeah. So the way this becomes useful, this is now your know your landscape dashboard that in any these pipelines had been fired for any state district tehsil and all those layers have been generated. Yeah. All those layers are basically sitting here. Yeah. The metadata is describing where those layers are sitting. Yeah. What the front end is doing is that for this area, these are all the micro watersheds in that area, and the data has been populated about these micro watersheds. That in these micro watersheds, what is the right different things, right? That is the terrain mostly plain. What is the difference in the max elevation to minimum elevation? Yeah. Similarly, land use, right? How much area in this is under crops? How much area is in this is under trees, and so on. Yeah. And so on, right? Climate, that does this area have any droughts or not, right? Like this part is very heavily drought prone. So they've had at least one drought since 2017. And what KYL then lets you do is that you can say that, okay, we could have chosen some other area. Um, Maybe let's say if we choose uh, this, or let's say if we choose this. Yeah, so now here you see a bit of a mix. There are some, okay, this is also mostly plain areas, but there are some areas which are like a mix of plains and slopes and so on, right? So in these plain areas, you can then see that, okay, show me which areas are more drought prone than others. Yeah. And these yellow boundaries are villages. So, yeah, which I'll just describe in a bit, right? So essentially, what the main point is that we are describing the landscape in terms of entities like micro watersheds, for which we populate all of these different things, yeah, land use and right, different kinds of agriculture statistics, how much area is double cropped, single cropped, and so on. So these are areas which are more single cropped, yeah. So a lot of these things are therefore, right, these are filters that you can keep applying that you can then think or ecologists, hydrologists can plan different kinds of interventions in these areas. Yeah. Then similarly, yeah, we extract water bodies. And similarly, for all of these water bodies, we know the size, we can say, okay, only show me small water bodies, don't show me water bodies on rivers, and so on. Yeah. So a lot of these things can be done, and then you can go further, right? You can look at any of these water bodies. So this is like a farm pond. You can look at a report of the water body and so on. Yeah. And similarly, you can look at reports of other things, right? That what kind of statistics have been populated for this area. Yeah. So now the main point, therefore, is that we are describing landscapes in terms of entities, and we are describing those entities in terms of variables. Yeah. So if you get to that point, yeah, then you can now start thinking that what else can I do with this? Because making these kind of filters is definitely one benefit that an agriculture expert, hydrologist, right? They can see that, okay, these areas have these kind of properties, and I can think that maybe some farm ponds or check dams might be more useful over here, or maybe some other kind of interventions might be more useful. Yeah. So that kind of a reasoning is what you can do. Yeah. Um, but can you also uh, somehow, right? So this knowledge is sitting in the expert's head. Yeah. That what combination of variable means what? What combination of variables means that this area is in groundwater stress? What combination means that this area is mostly rain-fed agriculture and it is very sensitive to delayed monsoons? Yeah. Or which areas face a lot of drought risk? So, what kind of a combination of parameters can tell us what kind of a risk is an area facing? Yeah. Um, and that is basically what we are trying to do. So, I'll close this piece. Yeah, that's what we are trying to do with core insights. That how do we, now this knowledge which is sitting in the head of experts, how can we somehow pull it out? Now, instead of experts, right, we don't actually have access to experts. We have access to research papers. Yeah, and we have access to LLMs that have read tons and tons of these research papers. So these are the same tehsils that have been populated on the core stack. Yeah. And you can go into any state district tehsil, and this is a micro watershed that opens up. Yeah. So just like we were seeing on Explorer, this micro watershed intersects with these villages. And these are some data sets, some properties that have been populated about the micro watershed. What is the area, right? What kind of a agroecozone does it fall in? What rainfall band does it fall in? What is the terrain like? And a bunch of other things, right? That is this under safe limits of groundwater extraction. This data is provided by Central Groundwater Board. Then what is the water balance like? Yeah. So this means that the rain that falls in this micro watershed, some of it will run off. Yeah. Because the nature, the slope in the land and everything, and not because not all the rain goes into the ground, right? So it runs off. And then some of that water will then be reused in agriculture. It will be reused to irrigate crops, and trees will also pull that water from the ground. So what is remaining, right? So now this area you're seeing is under negative water balance in many years, yeah, which means that more water, right? So somehow, right, there is this surplus getting financed. Either that surplus is getting financed by groundwater extraction, yeah, or I'm not surplus, right? The deficit, right? Or maybe there are some canals or something flowing through, right? Which are providing this. So actually there is a canal, right? Right. So this canal comes because this map was intersected with a canal map as well. Yeah. So all of this has been populated, right? Area of surface water bodies, cropping intensity. These are the same statistics that you saw on Noya landscape. What changes have happened, right? Cropping, farm to barren, farm to built up, tree cover increase, and so on. Yeah. So these are the same things, yeah. Now the point is that some village level information that what Nareka works have happened, how far is this village from a primary school, secondary school, health center, district hospital, 90 kilometers from a district hospital, but it's got a health sub-center in the village itself, right, within a kilometer. Yeah. So these are all things that have been populated um, beforehand. So you have all these variables describing this micro watershed. Yeah. Right. Now, what the tool basically does, maybe we can shift somewhere else, right? No pathway was confirmed, but this tries to tell us that for agriculture, I am uncertain whether this area gets a lot of droughts. Yeah. I am also uncertain whether forests in this area are encroached, are getting an encroachment or not. Yeah. I'm also uncertain whether forests are degrading. I'm also uncertain whether there is groundwater stress. I'm also uncertain whether there are irrigation challenges, and I'm also uncertain whether this area faces a lot of different social and economic stress that there's employment is affected, access to government schemes is limited, there is a lot of migration, right? So it's not certain about any of these things. I'm also not certain whether this area is mostly rain-fed and therefore it can face problems if monsoons get delayed or monsoons are less and so on, right? And I'm also not sure about so in this area actually you're pretty much not sure about anything, yeah. So we can, right, let's say close the diagnosis, and in this area you can run the diagnosis again. Okay, so now it's saying I'm pretty sure about at least one thing, that this particular area faces a lot of rain-fed risk. I'm not sure about other things. Yeah. So now how is this happening? This is happening basically that based on these variables, it runs these signals. It computes these signals, right? So one signal that it's computing is, let's read this, right? Mean Kharif cropped area upon mean Kharif crop plus double crop plus, this is just to avoid zero division, one, right? 10 power minus 9, right? So basically this is saying that of the cropped area in this, how much area is cropped during only Kharif, right? Single cropping, not double cropping. So if more than 75% of the area is mostly just single cropped in Kharif, yeah, and that's what you're saying, that most of the area is single cropped, double crop is very less. Then this is a like a correlation, that a single cropped, if the area is mostly single cropped, it means it doesn't have a lot of access to irrigation and it is mostly entirely dependent on monsoons. So it's more of a correlation. And this signal has a property for confirms that this signal to some extent confirms that this area will face rain-fed risk. Then similarly, there's another thing which is saying, is the cropping intensity less than something, and also the cropping intensity has not been increasing over time. So the trend in cropping intensity is pretty flat. Yeah, which means that there's not a lot of investment or anything also happening, right? So this signal also contributes further to confirming, right, what might be happening. Then another expression, that is canal name null, none, right? So there's no canals. And also in Narega, less than 35 irrigation works have happened in Narega. Yeah. So in this area, only 6 irrigation works happened. Yeah. Right. And the rule that this is following, right? Rain-fed risk is supported by landscape data, 3 of 5 confirming signals. So out of 5 signals similar to this, yeah, there's also signal 4 and 5, which is not shown over here. But out of 5 expressions which are likely to indicate rain-fed risk, 3 are coming out true. So there is a reasonable amount of certainty, right, that my policy is that I will confirm rain-fed risk when at least 2 primary signals, signal 1 and signal 2, are correct. Yeah. So you can go here and this gives more details, right? This is the full thing. Yeah. Yeah. That there's other signals also, right? Signal 4 looks at if the runoff is more than 80 and terrain cluster is 3. So terrain cluster 3 meaning this is a hilly area. So this is more for that if it's a hilly area and it has a high runoff, that also faces rain-fed risk because, right, when it rains, it might rain a lot, but a lot of the rain goes away because it's hilly. So by the time you don't have water throughout the year, basically. Yeah. This is not valid. This particular signal evaluates to false because this microwatershed has a terrain cluster ID of 1, which is mostly plain, right? Like what we are also seeing on the map, right? That is mostly a flat area. Yeah. So this is the idea that these signals and these are policies that it evaluates. Yeah. To determine whether some area has a groundwater or different kinds of a stress. Yeah. So these signals are for each type of a stress, drought, groundwater, irrigation. These are different, we call them pathways, right? These are different stress pathways. And so far we've populated for 8 pathways. And we've populated data for these 8 pathways in all these different agro-eco regions of India. Yeah. So there are some 17 regions that we identified. So 17 times 8. 136 is developed rules for these 136 cases, and is developed these kind of rules that I will say that an area is groundwater stressed, or this particular area, yeah, the area which is chosen, which is basically this particular area, the peninsula crystalline semi-arid, yeah, which is probably cluster 002, right? This dark green, this particular area. In this particular area, which is one of 17, for these one of 8 pathways, I was, right, these are the expressions that if state of groundwater is more than 90 or the state of groundwater is critical or overexploited, and if the trend in, right, annual, the average change in groundwater is negative, yeah. So these are the different signals that, right, some are amplified signals that situation can be even worse if the aquifer is of a particular type, yeah. Some are, right, so this is also amplifies that situation is worse if surface water count is less than 10. This is confirms, right, that the well depth is decreasing or not, right? So these are all the things, and then this is a confirmation policy that out of these three, if any two signals come out true, yeah, then I will say that this area has groundwater stress. Yeah. So similarly, there are rules for all these 136 cases. Yeah. Um, yeah. So if you're with me so far, yeah. So you're now getting the point that first CoStack brought a lot of data which describes micro watersheds, right? Rainfall, land use, land cover, changes in land use, land cover, terrain, all sorts of things. Yeah. And then here we have stitched those variables into simple Python evaluable logical expressions. Yeah. So these expressions are just written true or false. Yeah. So, right, up to 5 kind of expressions which return true or false. And then a policy which will say when to confirm, right? So, for example, these policies are simple, right? 2 of 3 are positive, are true, then you confirm. Yeah. If 1 of 3 is true, then you say I'm uncertain. Yeah. So these are the ones that were showing up in yellow over here. These are uncertain, right? One signal is true, 1 of 3 is true. I'm not very certain, but this one I'm getting more and more certain that 2 of these things are true. Yeah. So that's what's happening. Yeah. Um, so this is great. Yeah. Yeah. Now the question is, how did we develop these expressions? How did we come up with that these expressions are suitable for groundwater, right? And let's say this kind of a threshold, right? If alluvium aquifer is less than 20%, that is what we want to choose. Yeah. Um, yeah. So this is what we did in Core Insights. That so there's a blog also that I would have shared. Yeah, uh, yeah, which has all these details. Yeah, uh, maybe it's okay. Yeah. So this particular email has a link to the blog as well. Yeah. Um, so this blog describes how we went about doing all of this, right? So you can take a deeper look, but basically this is what we did. Let's say we start from here, right? We used regular web searches and in an automated way, right, to search for research papers from India. And then we chunked and extracted text from these research papers. And then we asked Claude to use these research papers and the variables, right? All the different variables in the core stack, yeah, of LULC and so on, to suggest what expressions are relevant, right? So the hope is that if Claude has right, if we give Claude some context about India, right, more right, we want to constrain it, right? That let's think about India. We don't want general rules about anything, right? So these papers will help potentially constrain that. And in addition, we provide a list of all these variables, right? So we built a data dictionary which lists all of these variables, and we gave that in the prompt to Claude. And then we asked it that can you suggest what sort of rules make sense? Yeah. And that's what it ended up giving us. Yeah. That these are the rules. Yeah. So now these rules, and then after that, what we did is we went through all of this manually. It had hallucinated on, right? Some of these expressions were not exactly Python expressions. Some of these expressions, although we gave it a list of variables, it cooked up some variables of its own, right? So we had to correct all of that. And we had to do a bunch of such kind of normalization, which we did manually right now. But that also can potentially be automated in the future. Yeah. I mean, LLMs are writing code. So what we're asking them to write is also code. It's just that we probably in the second try, we'll just be more specific about exactly how to write the syntax and specs and everything. And hopefully it should give us a better output. So it might minimize some of this issue, right? This normalization and everything. Yeah. And then the question is that all these thresholds that is giving us, right? Do these thresholds make sense or not? Yeah. Um, right. So these ones, right, is less than 10 a good threshold or is less than 20 a good threshold? Yeah. What sort of actually makes sense? Um, so what basically we also built to validate this. So this needs some ground truth, right? But so by the way, these you can also look at some of these links, right? There's a long list of all the variables that are in the core stack, right? Some 100 plus, right? What's the monsoon onset date? What's the evapotranspiration? Right? All sorts of things, yeah. Um, and uh, this one, this also, yeah, this is that across some 30,000 or so micro watersheds right now. What is the distribution of these variables? So this is basically what's called a cumulative frequency distribution. So this shows, right, what's the mean annual delta G, right? So it ranges from some negative to some positive, and we put in some simple tools, right? You want to chop off the top 10% or bottom 10%, right? Just so that you get a narrower band in which you can look at the values. You can convert it into a log scale. This one won't, it's got negative, but those anything non-negative, you can convert it to a log scale and so on. So this was useful to find out, right, what is the median, what is the 80 percentile, right? So because we wanted to figure out, right, at the thresholds that Claude is returning, is it returning a threshold which is like 10 percentile? Either returning a threshold more around 50 percentile. So this dashboard was useful for that purpose. Yeah. Um, yeah. Uh, and then what we did is we also built this triaging app. So we put up a list of some 30 case studies for which we knew the ground truth. So this is pretty much like a confusion matrix that you would see in a machine learning setup. Yeah. That these are the actual values, whether that area in these case studies, so these are micro watersheds, and we got some information from case studies that some micro watersheds have a drought risk, some have a groundwater stress, irrigation challenge, rainfed risk. Yeah, and these are the predicted. So this is called the confusion matrix. You basically want to be on the diagonal. Yeah, that if actually it's a drought, you're also predicting that it's a drought. If the case study is saying groundwater stress, you're also predicting that it's groundwater stress. Yeah. So you want to get as many of these kind of on the diagonal, especially the red ones. The red ones are false positives. Sorry, false red ones would be false negatives. That these are, yeah, these are areas which actually are drought prone, but you said that they are not drought prone. So that's kind of a big risk. You definitely want to minimize false negatives. Yeah. So what the triaging dashboard lets you do is that it picks up the stuff that Claude returned. Yeah. That these are the expressions that Claude returned, or we edited and we got something, and then it lets you edit these things. Yeah. So let's say now this one didn't get classified because it said that severe drought return period is 8. Yeah. So no, if you just want to look at these ones, right, the red ones, right? So you want to look at the red ones, and this is the one on which you made a mistake. That this is saying that severe return period is 8 and moderate drought return period is 2 years. Yeah, for this micro watershed, but your expression is saying that I will only trigger on true if this one is less than 4 and this is also less than 4. Yeah, but this one is 8, so the second one is fine, moderate, but the first one is not fine. Yeah. So if you do this, right, you say this is right. I want to tweak my parameters. I want this to be less than 8, and then you run this again. Yeah, uh, it did not shift. Oh, this one turned true, but this one is also false. Okay, so this is dry spell is 1, right? So let's say you turn this to 1. Yeah, and then you play again. So now it's gone. Yeah, because two of those signals turn true. Yeah. Of course, you can argue that, right, this choice doesn't make sense. Well, I'm just showing it for a demo purpose, right? But the idea is that you can fine tune these thresholds to get them right. Yeah. And then you can save them as patches and they go into the signal definition for that particular area. Yeah. So, plus, of course, so there's also another thing that we've implemented, a fine-tuning algorithm, which picked up these case studies and it tried to find better thresholds. Um, so now you can see most of these are on the diagonal itself. Yeah. It tried to find a better choice of thresholds automatically. So instead of manual tweaking that we were doing right now, that instead of manually tweaking some of these things, it automatically fine-tuned the thresholds, right, by incrementing, decrementing, and searching. And it got so that it could get more and more things aligned on the confusion matrix. Yeah. So technically, actually, the method is not very methodologically correct because the way this is done is that you should ideally have a holdout set on which you evaluate while you tweak your thresholds on another data set which hasn't seen the other one. Yeah. But we didn't have a lot of data, so right now it's set up like that. But the idea is that once you have these expressions, you can do all this fine tuning. Yeah. So yeah. So that's basically how this whole thing works. Yeah. That we went from looking at papers to describing to Claude what these variables, what is the list of variables we have, and then it built these evidence cards which show what sort of signals can work. Then we fix those signals, and then if we have some ground truth, then we can also fine tune the thresholds. Yeah. And what we get eventually as a result is this kind of an automated diagnosis. Yeah. For any micro watershed. Yeah. Yeah. And of course, right, there can be a lot of other improvements, right? So once we open it up, people can give feedback and so on. Yeah. And we can then consider some of that feedback and see if we can improve. Yeah. Um, so that is like the final, right, what we actually built. Yeah. Let me also talk a little bit about uh, how we got here and also give you an illustration of how powerful these LLMs are, but also what are the drawbacks and why we came up with this kind of a setup eventually. Yeah. So when we originally started building, our thought at that time was that rather than build these kind of rules ourselves, yeah, we can also go somewhere else, right? Maybe this one will have some hills and forest areas as well. I don't know. Maybe, yeah. Yeah. So, no, this is also mostly groundwater. So, uh, uh, what we first thought we'll do is that we'll just take all this variable, right? We'll just take all these variables and we'll just give it to Claude and ask it to figure out what's happening. Yeah. So remarkable thing is that it can. It is able to do that, right? It's so I'll explain what this setup actually is. But if we look at this, okay, yeah, we look at this and this. So this is some micro watershed for which we gave all this data. That was the stage of groundwater extraction, changes in well depth, cropping intensity, this, and all those other dozens of variables that you saw. And we asked Claude to tell that. I think I would have the thing written somewhere. Uh, this is the right. So we gave it all that data, and this is the task that we gave, that diagnose various problems in this landscape related to production systems of agriculture, right? Drought, groundwater stress, and so on. Yeah. And what Claude was able to do is look at this. Yeah. This is the output, right, for one type that is generated. Landscape data for this does not present the classic multi-sector vulnerability profile. The SC plus ST combined population is 34%, below the typical threshold for compounded social disadvantage. Literacy at 59% is moderate, and bank access is excellent. The bank is only within 0.23 kilometers, suggesting financial inclusion is not a binding constraint. Critically, there is no recorded severe drought across this period, yeah, which removes the most common trigger for multi-sector collapse in this region. Nareka count is 7, is low, but not critically absent. The pathway cannot be ruled out because household income and migration data are missing, right? In this. Yeah. So you can see, right? I mean, it's just it's figured out, right? It used the data, it figured out the thresholds kind of on its own. It believes that 59% literacy is okay, and it knows that banks within 0.3 kilometers is pretty good. Yeah. It knows that I should check for drought, and that drought return period of 8 years is not too bad. Yeah. Narega count is 7 is low. It knows that it is low, but it is saying it says it's not critically absent. Yeah. So it's pretty amazing. Um, uh, this particular thing is nice, but some others were very hard to understand. Maybe, yeah. Some others were pretty hard to understand, to follow the reasoning. Yeah. So the challenge that when we were just looking at the Claude outputs, the challenge was that now if you don't know anything, but you're about watersheds and so on, but you're keen to learn. Um, this level of detail, you're not able to learn from this kind of a organized prose, right? When text is presented like this, because it's generally hard to follow the reasoning. Then if you look at another watershed, you don't know, right, which ones, right? I just read something, but why is Claude not talking about that over here? Yeah. So it was hard to follow all of this, right? The other thing was that this also takes a lot of time, right? So it take right. So we gave it this long prompt, and it took like 60 seconds, 40 to 50, 60, 70 seconds, right? It was very over a wide range, right? To come back, right? So it's also taking a lot of time and so on, right? Um, Plus, maybe not in this example, but in many cases, we also observe some incorrect kind of, right? It was saying this is very low, but actually it was not so low and so on. The arithmetic sometimes was wrong that it was trying to do. Yeah. So that is why we said that, well, if the LLM already knows so much, yeah, can we ask it to give its output in terms of expressions? Yeah. And that was really the trigger for us, right? That if we are able to get expressions, then we can compute those ourselves. So basically, one way to think about it is that the reason that the LLM is able to generate this kind of a output is because somewhere in its internal architecture, those signals are triggering, or signals like that are triggering. And when we are asking it to tell us, right, which variables are important, which combination of variables is important, that's basically what the architecture internally contains. Yeah. So this is a hypothesis. There's more. I mean, if we have to actually test it, we'll have to right, look at different methods to right, really understand, right. That's the more intense research area around what's called neurosymbolic AI. But basically, what we have done is that we took the LLMs, we right that they know a lot. We gave it some more papers from India to kind of constrain their stuff that okay, think more about these parameters. And then we asked it in some ways essentially to describe the final sort of interpretable layers in its internal architecture, that what signals are basically helping it come up with a particular diagnosis, this diagnosis. Yeah. And the benefit we then get with all of this is that we get these signals, right? And the signals, like you saw, are straightforward to understand. Yeah. Yeah. I mean, it's intuitive, right? And Claude only gave this reasoning also that why am I giving this signal? What is the explanation, right? Um, so the signals are easy, makes it easy to understand. Evaluating the signal takes milliseconds instead of like a minute to do all that. So they're deterministic. Yeah. And you get the same output each time, right? So another thing with Claude and all these things is that maybe you give it again because there's inherent randomness. So you may get some slightly different kind of a response, right? But with this, you get the same thing. And then further, right, thresholds and stuff you can fine tune, right? So you can use it more easily. Yeah. So that was the benefit that we got from following this whole procedure. Yeah. So yeah. Um, so let me stop now. I've been going pretty much in a monologue all this time. Um, yeah. Uh, but I hope this gives you a sense of one, right, what LLMs are capable of. Yeah. They've ingested all this data. They can actually understand and tell you what's going on in a way that seems right. Yeah. Um, but sometimes you may not want to use just the verbatim output. You want to understand what's going on. And um, there is this kind of a method which might be fairly generic, like we applied it for micro shells, but the same method could be applied for farms, right? That what kind of signals are important to understand whether a farm is often distressed or not, right? It could be useful for water bodies, right? Any of those things, right? So that's part one, right, of what LLMs are capable of, and potentially how can we make them more amenable, their output kind of more amenable to being questioned, yeah, understood, analyzed, tweaked, yeah. So this is one way to enable some of that, yeah. The other thing is describing landscapes in terms of variables, landscape entities in terms of variables, right? So that is another important um, uh, method that we've developed in the core stack, um, which gives us a lot of power, right? That you can, right, like some of these CDFs and stuff that I was showing, right? You can understand how, diverse these landscapes are, what behavior, right? What's the range of these variables, and all of that can then be embedded into these kind of reasonings that can be done. Yeah. And then number three, what more can we do, right? Once we have these kind of capabilities. So now, right, we've basically described landscapes in terms of these single stresses, right? Whether it's groundwater stressed or surface water stressed and so on. But we can now also think about layers, right? In an area, right, which is groundwater stressed as well as rainwater stressed, rain-fed stressed, right? What should we do? Or if an area is rain-fed stressed but not groundwater stressed, then what should we do, right? So a lot of that very interesting kind of system level analysis can be done, where you can really understand that particular landscape in detail. Yeah. Um, Point number four, which I didn't show, is that in these diagnostics, right, not all the information has been seen by remote sensing. Yeah. So what we also have is that this guy then also comes up with questions which need to be asked from the community. Yeah, right? That have FRA claims been filed by community members, right? So this is basically important for understanding, right? That if FRA forest rights claims have been filed, then the community over here is pretty active, right? That if there is some forest area over here, if right, they've been filed but mostly pending, or they've been rejected, or some have been recognized, it shows that the community is more vibrant. So this information is of course not observed by the satellite, right? This we don't know, right? But we can ask the people from that area. And then, right, so this one, right, but the pathway ranking did not change, right? So it took this feedback, nothing changed in his diagnosis, right? Then it says, well, our fur is broken into small isolated patches. You say yes, right? And then it says that, okay, now I included this and I am now sure or more confirmed that encroachment is happening in this area. Yeah, encroachment into forest areas is happening. Yeah. So you can keep asking it new questions, right, which can help, right, about things that have not been observed externally, which can help determine the pathway. And this again becomes important because, right, we to recognize that not everything is observable. So just by sitting here, we can't tell everything. There will be uncertainties, but we can ask people, right? So it means that we need to involve more people into all of these questions. Yeah. So yeah. So let me stop now. I've been going on for a while. Um, and yeah, let's take any questions. Um, uh, yeah.
Have the follow-up questions also been sourced from the papers and the CSO reports that were fed into the system? Like how do you
Right, right.
that?
Yeah, correct. Yeah. So the list of these questions also, I mean, these were some, we gave it a list of variables that we are measuring, and then a list of additional variables that case studies were talking about. And we asked it to basically come up with, include those variables, whichever ones it wanted, include those into expressions.
Okay. Okay.
Yeah. Any other questions?
Adi, hi, this is Bilan.
Hey, hi, Milan.
Hi, hi. Is there like one for like maybe to pull out like areas for restoration or things like that? What do you think? Have you tried that? Have you seen anything like that? Do you already have that?
Matlab, we can trigger those expressions. Actually, I mean, we can potentially, in theory, run this on all micro shells. It's just that we've not done it right now.
Mm.
But I mean, if we go somewhere in, let's say, Odisha, and over here, I mean, I'm just sort of randomly clicking, right? So this one might be a forested area. So it does say that there's medium confidence that encroachment is happening in forest areas.
Mm.
Forest degradation is also happening, right? So it's kind of confirming
Oh,
things of this sort. Um, yeah, that forest being converted to farms. Yeah. So
mhm.
143 hectares, 143.9 hectares were converted from forest to farm. And the threshold kind of kicks in if more than 30 hectares are being converted. So that signal is true. Then urbanization is also happening. Yeah. So actually 115 hectares has actually converted to built up. Yeah. So those are right. So that's kind of what helped trigger these things. Yeah.
Thanks, yeah. Very nice work. Very interesting.
Yeah. But basically, yeah, I mean, if the signals are confirmed, then we can run this for all micro watersheds and we can get a scoring. that which micro watersheds are seeing some of these compounded, right? That there's forest degradation as well as groundwater stress and rain-fed risk, or right, whatever combination, right? We can get that. It's just that the interface right now is not set up in that way, but it's the logic is all there.
Thanks.
Yeah. Cool. Are there any other questions, folks?
Suppose a user wants to do the similar kind of analysis. So they need a paid tier of cloud to run the
Oh,
analysis.
yeah, I mean, I have right now, so Claude is paid. I mean, yeah, so the APIs are paid. Um, but right now it's not, Claude is not integrated. Right now, if you say, I want an LLM opinion, so actually another small detail that uh, we can see in, actually, let's do this first, right? If you run the diagnosis and you open this, uh, this is the analysis you're basically seeing from the server, right? But if you say that I want to include an opinion from the LLM, okay, you'll have to close it, yeah, and say that what stresses are playing out in this area, let's say, yeah. Then what is happening is that this is going to a locally running LLM. So this is on, right, this goes to a workstation which pulls up a local LLM into the GPU, and it's now running this. So this is not Claude, but the idea is that if this were Claude, then this would be an API that would go to Claude. Right now that API is just coming to my workstation, right, which is taking up, whatever this, about 75% memory. So this thing takes time, right? It'll keep going for about 60 seconds or so. And then it'll give an analysis where it will try to give, let me see if I can show you what that is. Uh, Okay, no, it should be here only, no, Claude, yeah. So this is the kind of opinion that it will give, right? That this was based on the rules, the evaluation, and it also tells you whether the LLM agrees with this or not. So here the LLM is saying, I agree. The server correctly holds this pathway, right? And so on, right? And it tells something, yeah. And this is its independent assessment. This is Claude's independent assessment that if it were not using the rules that we've given, it would use its own rules than what it gives. Yeah. So this one, it'll, oh, it crashed. Some issue. This I'll debug later. But basically it gives a, um, it basically tells you, right? So this is what we're calling keeping the LLM in the loop. Yeah, just like to understand AI, you want to keep a human in the loop to check whether it's doing right or not. Over here, we did it the other way, that you want to keep the LLM in the loop uh, to as a double check on what you're up to. I mean, what is your analysis correct or not? Yeah.
Okay,
So
uh,
that's how.
so a landscape manager can run without paying anything to cloud and using the
Huh.
fixed rules. They can get insights.
Correct. Right. Using the fixed rules, they can get anything. Yeah, they don't need, there's nothing to pay. If they have to use Claude, then, I mean, they won't pay. I guess we'll have to pay. But yeah, somebody has to pay Claude, I guess.
Got it. Got it.
there's just one point. Now, if we are doing this, we could even extend this it one step further. If we are already getting outputs from Claude, then we can actually fine tune any small 4 billion parameter model or 9 billion parameter model to using the Claude outputs, and then that fine-tuned model would be able to actually generate all these things based on this learning, and it would be free for then everyone else. Once we train it, we can upload it, and it would be free for everyone. They can use it on their PC.
Correct, correct, correct. So actually, that would be pretty interesting. That basically, can we, I mean, basically, can we extract these rules? Yeah. Can we, and it seems that it is possible. Yeah, that at least for micro. So actually, also quite interesting, right? That I think the point is that how much does the LLM know, right? And how well does it know the subject? Yeah. If it knows the subject very well, right, which is kind of evident if you look at the quality of the responses that we're seeing over here. Yeah. If the LLM is that smart that it understands this topic so well, maybe it can give us these rules. And maybe these rules, make sense. I mean, we can go through a human curation process just like we did and then do fine tuning, and maybe, it works. Of course, right? There's a lot of maybes over here because none of this has been validated. So there's
So
still,
there is
yeah.
a structured output option also, so that you can provide a JSON schema, and then it will output in that particular manner. So we could actually using Pydantic also, we can actually verify the
Huh.
कि आउटपुट सही से आ रहा है या नहीं, तो
Right, right.
वो
नहीं
increment
वो
कर
हाँ
generate.
हाँ yeah yeah no, it was done that way only. So the output was a structured JSON, but sometimes it hallucinated on the variable names, and sometimes the Python. So it basically needs an agentic loop, right? So right now, actually, I just manually fixed everything myself. But that's one of the next things that we want to try out. That because this manual tuning took a long time, but still, I mean, we want to just do it ourselves to kind of get a better feel. But yeah, I mean, this can be done by agents, right? So you get one level of output, get the agent to detect issues with expressions or like hallucinated variable names, and then you send it back and you iterate it over a few times till you get a syntactically correct output, and then you can use it further. Yeah. So the point, however, that I was trying to make was that if we are in a knowledge domain that the LLM understands very well, like hydrology, right? These things have been researched very extensively. Um, then maybe, that's all. Then we just need to extract these rules, and then we don't need to use the LLM anymore. Then we can just live on these rules and do various things, right? And that can be done for anything. It could be done for in the medical domain. It could be done like for farms. It could be done in anything, right? Um, because ultimately, what you need is like a rule based diagnosis capability. Yeah. But if you're in a knowledge domain that the LLM doesn't know a lot about, yeah, then what do you do? Then maybe it won't be able to give these kind of strong rules. Yeah. So that's also something. I mean, another group is working on some kind of climate, right, answering stuff. Um, and over there, we've taken a different approach, but we've not tried, right? We don't know how well the LLM can answer these kind of questions, right? That's a comparison we have yet to do. But assuming that, let's say, that's an area which is new research, the LLM doesn't know much or it's not ingested much about that area, um, then you need a different setup, right? Then you need more of some kind of a reasoning architecture which is more complex, and it extracts variables and relationships between variables and tries to do more, right? Then it's more complicated. Um, yeah, but I think it depends on the amount of knowledge that the LLM has actually ingested. Yeah. Yeah. Any other questions, folks?
Hi, Professor.
Yeah. Yeah, Sharja.
Yes, I have one question. So, can this interface be used by field researchers? If so, can they create custom survey instruments and upload or enter responses collected from sample respondents?
Responses collected. Yeah, I mean I wouldn't say, I mean, use this thing. You can use know your landscape and everything. Over here, the point is it's just a prototype right now. We're still really figuring things out. And plus, I mean, none of this has been validated. So I wouldn't say it's ready for like field use. But we can take, I mean, we would very much like to take yours and other people's help to get more information, right? And like look at some of the outputs, tell us whether it's doing it correctly or not. And then we use that to fix things, improve things.
Okay. So it will take some time, or is the work is still in the progress?
Right. Yeah. No, this thing definitely is work in progress, right? I mean, it's definitely, I wouldn't say in any way, right, that is ready for use in the actual setup.
Okay.
Yeah.
Sir, I wanted to say that like some of the materials is being researched. So one example could be given a climatic zone and this particular change over the weather pattern observed there for the last 5 or 10 years. What are the risks of a particular neurological disease? Like this thing is being researched. The neurological if the effects of climate change on our neurology.
Effects of, yeah. I mean, people are definitely looking at intersections of climate and health. Yeah. And heat is a big thing in that. Yeah. Cool. Um, okay. So, folks, if there's no more questions, then we can stop. Um, but I'd really encourage you to kind of play around with this, send feedback. And also, I mean, in general, I think explore some of these areas. Yeah. I think there's a lot to do. The LLMs are very powerful, and we have yet to kind of really figure out how to best make use of them. Um, I think, right, what we should shy away from is just being happy with this. Because I think this is kind of just giving all our agency away. Then we wouldn't bother about learning anything. We'll just get all our answers straight away from here. But I think using it to extract knowledge, right, is an interesting way to think about it. Extract knowledge in a way that we can use it, we can understand, we can explain what's going on, we can tweak it, we can learn from it. I think that's really the way to go. Yeah. Cool. So, great. So let's
I
stop there.
sorry, I
Yeah.
had a question, if it's
Yeah.
okay.
Yeah.
Yeah, yeah.
Go ahead.
So first off, it's really cool to see this. I love the idea of creating the pathways and then the signal for each and creating a deterministic output for that. That was amazing to see. A thought on I was wondering about uh like with regards to validation, I was wondering if there's feasibility to say limit the data for okay, use pre-23 data and then potentially check like newspaper reports to validate. something like if you can limit it and then say, okay, is this area drought prone? And then check whether there are newspaper reports which say that there are droughts or tankers required in this region, like that. Um,
Correct, correct. Actually, Tara,
mm,
that is exactly what we did. So that ground truth that I was talking about of 32 case studies,
right?
that is exactly how it came about. We actually
Oh, okay.
used, yeah, we basically used reports published by partners like FES, Vasan,
Mm,
Water, all these organizations about interventions that they had done. And so this was like actually the very first phase. So we
mm,
basically used all those case studies and we ran them through LLMs, and it helped us organize it under different production systems. So agriculture is a production system, livestock is a production system for which we haven't developed the pathways as yet, right? NTFP
mm,
forest diversity is a production system, fishery, right, and so on. So these are all production
mm,
systems, and within each system, these are observed stresses, that water scarcity is a stress, which could be caused by groundwater or drought or rain-fed or irrigation challenges. Yeah. And for each of these, we had these long list of case studies, right? So overall,
okay.
there were some, we finally got it down to about 300 case studies, but overall, I think
Mm,
the spurious and, right, there was some more than 600 kind of stuff that was obtained.
mm,
And from those, we are still in the process of exactly getting the ones to use for ground truthing. But right now we used about 32, for which in the case study there was information about the exact village, and we were able to also find the village and get the exact micro watershed they were talking about. So that is exactly what we use to say that, okay, the particular micro watershed on which we have all these variables that actually has groundwater stress, or that has been reported to have drought stress or rain fed or irrigation challenges and so on. Yeah. So you're absolutely right. I mean, newspapers or NGO reports to get case studies, that's one way to get the ground truth. The other is, of course, to actually get on the ground and collect it. Yeah. So yeah,
yeah.
yeah. Great that you brought it up because I kind of skipped it. It was just going into too much detail. But yeah,
Very cool work. Thank you.
great. Thanks. Uh, yeah, Nareka work was done by scraping Nareka website. Yeah, 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 correct, correct. Yeah, cool. Uh, great. So, folks, yeah, thank you so much for the questions and feedback. And yeah, I mean, yeah, I don't know how to turn off sharing. Do take a look and play around. I think this is just really scratching the surface. I think there's a lot we can do with these kind of approaches, and even this thing has a lot more work to be done. But I think there's a big opportunity. Yeah, cool. So let's stop now. Um, great.
Thank you, sir.
Thank you, sir.
Thanks. Thanks, everyone. Bye.